2-6 geometric proof. Pause the video and try this warm-up. 2-6 geometric proof. So we're going to focus on writing a geometric proof today. And we know that a conditional statement has a hypothesis, and that leads to, we hope, a conclusion. So when we write a proof, what goes on is we take our hypothesis and then we write an argument that contains either definitions, postulates, properties, or theorems that prove our conclusion. So this is what a proof looks like in a verbal model. So write a justification for each step, given that angle A and angle B are supplementary and the measure of angle A is 45 degrees. So the first kind of question you'll have is you'll be given the steps of the geometric proof, and we're just going to practice coming up with the reasoning, your justification. So if angle A and angle B are supplementary, the measurement of angle A equals 45 degrees. You'll recall from yesterday that the first step is typically what has been given to you in the problem, and this all was given. So we would just say given information. The next step, we see measure of angle A plus the measure of angle B equals 180. So what description would justify this? And supplementary 180, angle A and angle B. Yep, you got it. That is the definition of supplementary angles. Angle 45 degrees plus measure of angle B equals 180. So where did this 45 come from? In line 2 it said measure of angle A, and we can see that this is given information, isn't it? So we're taking information and inserting it. What do we call that? Substitution. Good. Substitution property of equality. And at this point, what happened to get move this 45 away from the unknown measure of angle B? What did we have to do? You got it. We used to call that inverse operation, but now you know we call that the, in this case, subtraction property of equality. Subtracting 45 from both sides of this equation gives us this more simplified equation. And we now have the measure of angle B equals 135. Let's try a second we have the given steps, and let's try writing the proof for this second geometric example. Just pause the video and take down the data, take down the information, and see if you can complete the justification yourself, and then come back. Hopefully you have all of the information down now, and let's see. B is the midpoint of AC. So once again, we start with the given information, don't we? Okay. And now we go to segment AB is congruent to segment BC. How do we know that? That's not given. So we do know that B is the midpoint of AC. So AB and BC are segments with the same midpoint, right, to those endpoints. So that's the definition of a midpoint, isn't it? That it divides a segment into two congruent segments. Good. And the third step, AB is congruent to EF. Where did this come from? AB and EF. It came from the given information, so more given information. And finally, if AB is congruent to BC, and AB is also congruent to EF, BC then must be congruent to EF, the transitive property of congruency. Okay, we know what a biconditional statement is, and we know that it can help us define something. It can help us create a definition. A theorem is something a little different. It's not a biconditional statement. A theorem is, however, a statement that you can prove. A statement that you can prove. Once proven, it could be used to in a proof for justification of a step. So we have a couple of theorems introduced in this section. The linear pair theorem. So when we start dissecting these words, linear, what's the smaller word you see? Not ear, but line. So if I have a pair of angles that form a line, they must be supplementary. Together they form a line. We have then supplementary angles. The second theorem introduced here is the congruent supplements theorem. So supplements, that word looks like supplementary, 180. We must be talking about angles again. So if I have an angle, angle A is supplementary to angle C, and I have another angle, angle B, it's also supplementary to angle C, then angle A and B must be congruent, right? So if two angles are supplementary to the same angle, then the two angles are congruent. We're going to pause and have lesson quiz part 1 today. We're going to take 2 days in this section, geometric proof 2-6. So pause and please attempt to write the justification for each step in this given proof. For the measure of angle ABC equals 90 degrees and measure of angle 1 equals 4m angle 2 equals 4 of the measure of angle 2. Interesting. Okay. Okay, hopefully you paused and you have some justification for these steps in this proof. So let's start with step 1. Measure of angle ABC is 90 degrees, and the measure of angle 1 equals 4 of the measures of angle 2, or 4 times the measure of angle 2. So this information we know is given. Angle 1, measure of angle 1 plus the measure of angle 2 equals the measure of ABC. So when we look at ABC, how do you justify that step? Good. It is the angle addition postulate. 4 of the measures of angle 2 plus the measure of angle 2 equals 90 degrees. Well, in this first step we see that angle 1 equals 4 times the measure of angle 2, right? So we're taking information given and plugging it in. So we call that substitution. Substitution property of equality. If you wrote that whole thing out, great. Next step, what are we doing? 4 measures of angle 2 plus the measure of angle 2 equals 90. We now have the 5 measures of angle 2 equals 90. So we simply simplified the left side of the equation. We call that simplified. And finally, the measure of angle 2 is now alone. We are missing the 5. And 90 degrees has become 18. So what happened? Both sides divided by the same value. So the division property of equality. Good job. So here is your assignment for day 1 of 2-6. Have fun.